All right, y'all. So as promised, here is number 5 of the titration practice problems. So number 5 says, what volume of 2.0 molar HNO3 is needed to neutralize 40 milliliters of 5 molar NaOH? So this one is a multi-step because, as you can see, we don't have any of the products. So we're going to have to predict the products. So that's step number 1. Step number 2 is balance the equation. And then step number 3 is going to be the actual titration equation, where we use the equation C1V1 over N1 equals C2V2 over N2. Okay, so right away, what I can see, and actually let me make this a little bigger. There we go. What we should be able to see is, if we look at the first compound, it's multiple elements, and the second compound is multiple elements. And so this is most likely going to be, actually, let's do process of elimination. It can't be decomposition, because decomposition and types of reactions is one compound that breaks apart into multiple. It's not synthesis, because as we can see, we have 2 products, not just one. It's not combustion, because we don't have O2 combining with a compound that has C's and H's. And so it's either going to be single or double replacement. So over here, this compound doesn't have an element that's by itself, and this compound does not have an element by itself. So the only other thing that it can be is double replacement. So because we have been talking about acids and bases, we should be able to see that this H is in front of NO3. So that's most likely going to be our acid, where H is going to become an H plus when we put it into water. And NaOH, well, that OH is going to increase the amount of OH if we put it into water, creating the base. So our acid right here, that means that when we react, this H is going to be our positive, and the NO3 is going to be our negative. So for now, all we care about is just which one is positive, which one is negative. Na should be positive. If you're not sure, you can always look at the common monoatomic and polyatomic ions, and it shows Na right here. So Na is a positive. Na is our positive, which is going to make OH our negative. So when we do that, we can see which ones are going to switch out. So you can either switch both of the negatives, so that way we still have a compound that has a positive and a negative, or we can switch out the positives. And again, that way we still have compounds that have positives and negatives. So I'm going to go ahead and switch out the H and the Na. Okay, so we end up having NO3, NO3, and then over here we have HOH, which hopefully you can see that this becomes water. So HOH, it's one oxygen bonded to 2 hydrogens. So this is H2O. We can rewrite it as H2O, which is our liquid. And then AQ just means it is aqueous. And again, aqueous means that it's just dissolved in water. And remember how I said when we neutralize, the H positives react with the OH negatives to become water. Okay, so these are our products. Let me go ahead and erase the HOH and move up our H2O. Okay, now we are going to balance. So let's go ahead and list all of our elements. We have H, we have N, we have O, and then we have Na, and then O we already have down, and H we already have down. Okay, so over here I'm going to list them in the same order I listed them in the first one, just so I can keep track of them a little bit more easily. Okay, so H's, let's go ahead and count all of our H's. Actually, let's pause here. I have not checked to see if we have this in the correct ratio. So this might change a little bit. Okay, so this time we have to see what is the plus and the minus. How is it a +1, a +2, +3, -1, -2, -3? So let's check our polyatomic ions to see what it is. So if it's just 1, 1, 1, 1, like with the H and OH, then we're good because we don't need to add multiples of the H's to create a neutral compound. So let's take a look. Na is if we see over here, we don't see a number next to the plus. So if we don't see a number, that means that there's an imaginary one. So Na is just +1. So it's just a plus. And NO3 is just a negative. We don't see a number next to it. So this is just a negative. Over here, the nitrate. So NO3 is just a negative. We don't need to change how many copies of Na or NO3 we need. They cancel each other out perfectly. Okay, and then H and OH. H is plus. Again, it does not have a number, so it's a 1, so +1. And OH, hydroxide over here on the very left column, hydroxide OH minus, it doesn't have a number, so again, it's -1. So they fit perfectly. H is +1 and OH is -1 to create H2O. And if you need to see that again, so it's H and OH. H is a positive one, and OH is a -1. So because they cancel out perfectly, we don't need to make extra copies of the H plus, so we don't need to have H2OH. We're good with just HOH, which we could rearrange to say H2O. Okay, now we can balance. So we're good. We didn't need to change anything of Na, NO3, or H2O. Okay, so let's balance. Hydrogens, we have 1 hydrogen from our first compound and 1 hydrogen from our second compound. So 1 and 1, which in total makes 2. Nitrogen, we have 1 from our first compound Oxygen, we have 3 from our first compound and 1 from our second compound. So 3 and 1, which makes 4. And Na, we only have 1 Na. Okay, so now let's take a look over here on our product side. Hydrogens. We have both of our hydrogens on H2O, so we have 2 hydrogens. Nitrogen, we only have 1. Oxygen, we have 3 on the first compound, plus 1 on the second compound, so 3 plus 1, making it a total of 4. And then Na, we have 1. So let's take a look. H's, 2 H's over here, 2 H's over here, we're good. 1 N over here, 1 N over here, we're good. 4 O's over here, 4 O's over here, we're good. And Na is good, and Na is good. So that means that we didn't have to change anything, which means that this, we have 1, 1, 1, 1. Okay, and that is our balanced equation. Thankfully, we didn't have to do anything. Okay, now now that we have done predicting the products and balancing the equation, now we can move on to our C1 V1 equals C2 V2. So let me go ahead and make a copy and paste it, bring it down, make it smaller. Okay, so let's go back at the question. So what volume of 2.0 molar HNO3 is needed to neutralize 4 milliliters of 5.0 molar NaOH? So our hydrogen, I'm going to go ahead and, let's see, highlight that in this tone, and our so that's our acid and our base over here. I'm going to highlight all of our information for our base. So for our acid, all we have is the concentration. But for our base, we have the volume and the concentration. And of course, for everything, because we have our balanced equation, we also have our N's, our molar, our numbers of moles. Okay. So for our acid, we only have C1, right, which is 2.0 molar. Our V1 is unknown, and our moles is 1. For our base, our concentration is 5.0 molar. Our volume, remember, this is in milliliters, but we need it in liters. So we're going to take 40 and divide that by 1,000. And that should be 0.04. You can put 4 or 40. Either way, it's still the same number, 0.04 liters. And then again, the balanced equation, for NaOH, we have a coefficient of 1, so our N is also 1. Okay. So let me go ahead and write that as an equation. So 2.0 molar times C1 over 1. And then because we have over 1, anything over 1, anything divided by 1 is just the number itself. So we can kind of simplify it already. So I'm going to go ahead and take that out. So the 1 and 1, If they were different numbers, then we would want to include it, but because it's the same thing, it's one, we can basically ignore it. Okay, and then we have our C2, which is 5.0 molar, times V2, which is 0.040 liters. Okay, so let's go ahead and simplify our right side. So that's going to be 5 times 0.040. Let me go ahead and do that. 5 times 0.04. And that is going to be 0.2. And over here, let's bring this back. So we have 2.0 molar. And then actually this is volume. Sorry, volume. V1. Okay, so now from here, now that we've simplified this part, so again, let me just double check. 5 times 0.04. Yep, 0.2. And let's go ahead and divide. So get V1 by itself. So divide 2.0 molar, divide 2.0 molar. Okay, so go ahead and do that math and let's see what we got. So we have 0.2 divided by 2, which equals 0.1. And because this is volume, this is going to be our liters. Okay, and so this is our answer. If we go back to the question, it asks, ooh, what happened there? Okay. If we go back to our question, it asks what volume of our acid, of our 2.0 molar acid, is needed to neutralize 40 milliliters of our 5.0 molar NaOH, and that volume is 0.1 liters, or if you want to put it into milliliters, instead of dividing by 1,000, we're going to multiply by 1,000. So 0.1 times 1,000, and that's going to be 100 milliliters. So both of these are correct. All right, and that's how you solve for question number 5.